Okay, this is chapter 9. This is section 9-1. This is recording number 5. Okay, this next little very short topic here is he says that the researcher will sometimes be interested in testing for some sort of a specific difference in the means other than 0. In other words, and it's a little bit confusing here. He says in testing a specific difference in means other than 0. What he's saying there is typically we have a null hypothesis is that mu1 equals mu2, so the difference in these means is 0. That's the typical scenario for the null hypothesis, but that's not required. We could have a different type of a situation. So that's what he's trying to say there. Okay, so for example, the researcher's hypothesis. So the research hypothesis is that, okay, I had a little technical difficulty there. So let's say, for example, that the researcher thinks that on average, the nursing students at a community college are 3.2 years older than those at a university, which makes sense, right? People will sometimes have other obligations and they don't get back to college after high school for a little while. So it's conceivable that the average age on a community college campus is 3.2 years older than those at a university. So his research hypothesis is that mu1 subtract mu2 is greater than 3.2 years. Well, the researcher has the burden of proof. So the null hypothesis would be that it's precisely equal to mu1 take away mu2 is precisely equal to 3.2. The researcher thinks it's more than 3.2. The null hypothesis says that it is exactly 3.2. Okay, so the formula is still the same, but right here, instead of being mu1 take away mu2 is 0, instead of having that as being 0, in this case, it's 3.2. So that's what gets plugged in there. The calculation is exact same. So, when you're up here doing the calculation, you plug it in. Instead of getting 0 there, you get 3.2 as the null hypothesis value for the difference of mu1 take away mu2. Okay, so that seems pretty reasonable. I think that you guys can handle that. He didn't give you any examples of that, but it's a very simple concept. Okay, so now there's another way of thinking about all this stuff, and that is the so-called confidence interval. So you remember we talked about confidence intervals before, and a confidence interval, if we know the standard deviation or and the variance of the population, we will use the z-score we'll use the z distribution for the confidence interval if we're talking about means. Did you remember that? That was in chapter 7. Let me see if I can find that. Here's the summary page for the formulas. In chapter 7, gosh, I hope I can get you to read that better there. I'm sorry, it's not very clear. Okay, back in chapter 7, these are the important formulas at the end of the chapter. This was the formula for the confidence interval of the mean if you know what sigma is. So you got mu is in here, is between x bar plus the margin of error and x bar subtract the margin of error. So that's what we had before for mu. So I recommend you get your book out and look at that chapter 7 and then compare that with what we have now in chapter 9. It's the same, okay, except that in the middle here, we have mu1 take away mu2, because we're not interested in mu, we're interested in the difference between the mu's. This mu1 take away mu2, that's what we're interested in, is the difference, okay? But it's going to be between, here's the corresponding point estimate, x bar 1 take away x bar 2, plus or minus the margin of error. The margin of error is the appropriate z value times the standard error. Okay, so I claim that this is equivalent to this. So you need to look at both of those kind of next to each other, and I hope you'll agree with me that that's what's going on there. So the point of this is that in a typical scenario, when we have a null hypothesis, is that mu1 take away mu2 is equal to 0. Well, if we can get the confidence interval, we'll have something over here on the right hand side, something over here on the left hand side. If 0 isn't in the middle here somewhere in there, then the null hypothesis should be rejected, because there's not a, let's say alpha is 10%, so there's not a 90% confidence level that there's not a 90% confidence level that mu1 take away mu2 is equal to 0. Okay, so we're using this confidence interval to do our hypothesis testing. So here's an example right here. Okay, so he says, find this 95% confidence interval for the difference between the means in example 9-1. So let's look at what 9-1 was. Okay, 9-1, that was the example talking about the leisure time, where you had the two different age groups of people that were spending time on leisure activities. Okay, so the null hypothesis, mu1 take away mu2, or I'm sorry, the null hypothesis is that mu1 is equal to mu2. Well, the null hypothesis can also be expressed by saying, well, it's mu1 take away mu2 is equal to 0. So we want to know, is that value of 0, is it in here in between the two, the right hand side and the left hand side? Okay. Or perhaps you're not even interested in hypothesis testing. Perhaps for whatever reason, what you want is you want to know what is the 95% confidence interval for this difference here. And if you don't mind, I'm going to introduce a new word to you, because I've been avoiding it all this time, but I don't know why. The mathematical term that we always use is delta. Delta. D-E-L-T-A. Delta. Delta means the difference. Whenever you're talking in math about a difference, you say delta. So the delta mu is the mu1 take away mu2. So let's suppose for whatever reason you want to know what the 95% confidence interval is for the delta of the mu's. Okay, well, it's relatively simple. It's just going to be the point estimate, which is the x bar 1 take away x bar 2, plus or minus the margin of error, just like we had before. Okay, exactly the same, but obviously different things are going to be used for the various portions of the formula. Okay, so we know what x bar take away x bar 1 take away x bar 2 is. We got that right in there. We know what z sub alpha over 2 is. That's 1.96. We know what this is. So it's just a matter of writing down the formula. Please do me a favor. Always write down the formula, and then you just plug things in. And here's what you come up with. The confidence interval, the 95% confidence interval is 1.4 to 7.0, and the delta is not in here, or the delta, but mu1 take away mu2. The null hypothesis would say that that's equal to 0. Well, 0 is not between this number and this number. Therefore, we would reject the null hypothesis. So that's what he's saying right here. Okay. And that agrees with our previous result. That's the way we did it before. Okay, so that's the end of this chapter. Obviously, there's more applying the concepts. I urge you to look at those. I think they're very well worth your time. There's too many exercises to do all the exercises, but you could at least look at them to get an idea of what kind of examples might be more interesting for you. It depends upon what your interests are. You'll find something that you like and that you can you can kind of feel like, hey, this is something that I could get my arms around. Okay. Here's one talking about lengths of hospital stays. You could change that very, very easily. Instead of talking about the number of days that you stay in the hospital, you could say the number of days that you're sick, and then this could be this column here could be the column for people that took the medication. This could be the column for people that did not take the medication, and you could easily do these kinds of calculations that apparently the newspapers can't do, because they never did it in that article that we were talking about earlier in my first recording today. All right, so there's several examples. Hopefully you'll find one that's of interest to you. So that's the end of this tape, and this is the last recording for this section 9-7, or excuse me, 9-1. This is the last recording for section 9-1.